Welcome to lesson 3-2, standard deviation, and there's just one video for this lesson. So we're just going to dive right into finding the standard deviation. Alright, so our learning target today is that we can find and interpret. This actually should not say mean absolute deviation. This should say standard deviation. I should have changed that before I made the video, but I just now caught it. But this should say standard deviation of a given data set. So our vocabulary word over here is standard deviation. All right. So the standard deviation is a measure of the variability of a group of numbers. It means how far spread out the numbers are, or how not far, for lack of a better way to phrase that, those data values are spread out. So if your data values are all smushed together, that's a lower standard deviation. If they're spread apart, that's a higher standard deviation. And this right here is just a visual for you to have of the normal bell curve. And this shows 1, 2, and 3 standard deviations to the right of the mean being 0. You'll see later, well, not in this course, but you'll see in later stat courses why that makes a little more sense. But anytime you have the standard deviation on the bottom here, 0 is your mean. And these are represented really by z-scores. So -1, -2, and -3 standard deviations to the left. And you'll see here that most of my data will fall within 3 standard deviations of the mean. So this section of data here is about 68%. This section of data here ends up being about 95% between 2 standard deviations. And then within 3 standard deviations is almost 100% of your data. All right, we're going to dive into an example here on how to actually find the standard deviation by hand. So the first thing we want to do is we want to list our numbers in this table here. So my data values I'm going to list over here to the left. So that'll be 52, 48, 60, 65, 59, and 54. Then I'm going to grab my calculator and I'll go to data. I'll clear out my data and I'm going to plug these values in here to find my mean. So 52, 48, 60, 65, 59, 54. So I should have 6 total data values: 54, 59, 65, 60, 48, 52. Just making sure I plug those in right. Then we'll do second data, hit enter on one variable stats, and calculate our one variable stats. So our mean is x bar here, which will be 56.33, and I'll round to 2 decimal places. So 56.33 is going to go straight down here. So this will be 56.33, 56.33, 56.33, 56.33, and 56.33. Okay, so our second column is just our mean, and I wrote it 6 times over. Now our next column here is that we must take now our data and subtract our mean. So let's do that over here. We'll do 52, our first data value here, 52 minus 56.33, and that's going to give us -4.33. And then we'll do 48 minus 56.33, and that'll give us -8.33. And then we'll do 60 minus 56.33, and that'll give us 3.67. And then we'll do 65 minus 56.33, which is 8.67. And then we'll do 59 minus 56.33, and that'll give us 2.67. And then lastly, we'll do 54 minus 56.33, and that will be -2.33. Okay, so we have now put our data in here, we've calculated the mean and put our mean here, and then we have subtracted our mean from our data and we've placed all of those data points here. And now what we must do is square each of these values. Now remember, anytime you square a negative, it's going to become positive. If you plug that in your calculator, once I go through here for this last column here, I've got to square each of those. And if it's a negative, you've got to make sure you plug in parentheses. So that'll be 18, and I'm still going to round to 2 decimal places, so 0.75. The next one will be parentheses negative 8.33, close your parentheses, square it. That'll be 69.39. And then we have 3.67 squared. And I didn't use parentheses on that one because that's a positive value. So that'll be 13.47. 8.67 squared will be 75. So 75.17 when I round to 2 decimal places. 2.67 squared, that'll give me 7.13. And then lastly, a negative 2.33 squared gives us 5.43. Okay, so let's recap all we've done here. So we have our data. We find our mean from that data, we put that here. Then we do data minus the mean, so data minus mean, and put that here. You're going to have some negative values, you're going to have some positive values. I chose to round to 2 decimal places. The problem will tell you what you need to do, but on this one I just decided to round to 2 decimal places. And then here I squared each of these values. So I squared this value all the way down and put all of those here. Okay, so now let's move on to this next part down here. We want to find the sum of all of these here. So we'll do 18.75, and we're going to add, let me do all that at once, 18.75 plus 69.39 plus 13.47 plus 75.17 plus 7.13 plus 5.43, and that will give us a total of 189.34. And then it also wants us to evaluate n. That's the total number of values I have. So I have 1, 2, 3, 4, 5, 6. So n is equal to 6. So for the variance, we need to calculate the sum divided by 6. So I'll just divide my previous answer by 6, and that gives us 31.56 if I round to 2 decimal places. Now, at some point, y'all are probably thinking, well, I'm squaring them, but I've got to take care of that later. We actually take care of that right here in the population standard deviation by taking the square root. So we're going to take our answer, and we're going to square root it to get 5.62. Now, the trick that I just used there is I did second root and then second answer. And what that does is that takes whatever my previous answer was and puts it underneath the radical there. Now, one more thing I want to mention is, or first off, let's just mention this is my standard deviation. And if I go over to one variable stats of the same data that I have and I scroll down to line number 4, you'll see this is the population standard deviation, 5.617. We rounded to 2 decimal places, so this ends up being approximately the same. So we got it right. And we did all this by hand. And so your calculator is doing all of this behind the scenes whenever you ask it to find the standard deviation. So the population standard deviation is line number 4 under one variable stats. Okay, line 3 is the sample standard deviation. For this class, you're going to use the population standard deviation. More often than not, in most statistics, you actually will use line 3 for the sample standard deviation, but for Algebra 1, we're going to use the population standard deviation. Okay, so that's what you need to remember from here on out for the rest of this class. Now, I have these steps written for you here, so there is a U-try that I like for you to try. And other than that, oh, actually, you know what? Nope, we do have one more thing to talk about. You need to fill this in your notes. So the standard deviation allows us to better understand the spread of the data. The higher the standard deviation, I talked about this before, but the higher the standard deviation, the more spread out and inconsistent your data is. The lower the standard deviation, the closer together it is, and the more consistent your data will be. So a higher standard deviation means less consistent. A lower standard deviation means more consistent. Example number 2 here asks us which data set shows more consistency. Group A with a standard deviation of 5.9 or Group B with a standard deviation of 2. Well, Group B actually shows more consistent data because it has a smaller standard deviation. What that means is that on average, its data values are closer to the mean than Group A, because Group A has a higher standard deviation of 5.9. So Group B actually is more consistent than Group A because their standard deviation is lower. All right, now that's it. So try the U-Try, and then I will see you in the next video.